Algebra 1, we are in lesson 15 of Unit 5, learning about functions involving percent change. We're still an exponential unit, so we're rolling right along with it. All right, so let's start. 15.1, Dandy discounts. All books at a bookstore are 25% off. Priya bought a book originally priced at $32. The cashier applied the store-wide discount and then took another 25% off for a coupon that Priya bought. If there was no sales tax, how much did Priya pay for the book? Show your reasoning. So all books are 25% off, and then she got another 25% off. So we need to carefully calculate her total that she spent. Now, if she got 25% off, we wanted to use that exponential type math, what would we multiply the cost of our book by? 75%, because that would be our amount remaining. Now, I'm not going to use 75% because that would be silly. I'm going to change that into a decimal. Now, that's going to give me an answer, but I need to do another 25% off. So I'm going to multiply by the amount remaining again, which we learned in the last lesson is sort of like multiplying by the amount remaining twice, or to the second power. So you can do times 0.75 twice, or you can do times 0.75 raised to the second power, and I get the cost of the book is $18. So 15.2, owing interests. I don't know if you guys know how loans work. So if we were in class today, we would talk about it. If you're unfamiliar with the idea of interest on loans, you should know that if you borrow money, the bank that you borrow it from charges you interest. So you end up owing more than you borrowed because they want to get paid for letting you use their money, right? So if you borrow some money, you end up paying back more than what you borrow. That's just how loans work. The company that lends you money wants to make a profit on lending you money. So a person or a bank may lend money to someone who needs it. And in return, the lender would collect interest, which is a percentage of the loan until the loan is paid. Another example would be if person A decides to borrow $400 from a lender at a 10% interest rate, calculated yearly, then after 1 year, person A will need to pay back the lender $400 times 0.1, which is that 10% interest, or $40 just in interest, in addition to returning the borrowed amount. So really, they owe $440 total back to the lender. Okay? All right. So let's look at this example. So to get a new computer, a recent college graduate obtains a loan for $450. She agrees to pay 18% annual interest, which will apply to any money she owes. She makes no payments during the first year. So number one, how much will she owe at the end of 1 year? Show your reasoning. So the amount that she owes is the amount she borrowed plus the interest rate. So really, we're at $450 times 1.18. Remember, we talked about that last week. This is like 100% of $450 plus 18% interest is 118%, but we need to move the decimal back, so 1.18. And that gives us, do the math, calculator, $531. Make sure when you get your answer, you think about it. Like if your answer was less than $450, you may have done something wrong. Now you could always do $450 times 0.18 And that would give you $81. And then you'd have to take $450 plus 81 to get 531. It's just an extra step, which is sort of unnecessary if you know how the math works. All right, number 2, I'm going to have to move to the next page, but I'll read it first. Assuming she continues to make no payments to the lender, how much will she owe at the end of 2 years? 3 years. So that was the end of 1 year. It means at the end of 2 years, we're going the same exact interest again. And that's going to be, do some math, $626.58. Okay, do that again. The dog is snoring under my feet if you hear her. She's exhausted and wants us to go back to school desperately. All right, that one is going to be $739.36. So this chick really needs to start repaying back her computer, right? Question 3. To find the amount owed at the end of the 3rd year, a student started by writing. So the student wrote this, which you have in your binder in front of you, and ended with 450 times 0.18, times 1.18, times 1.18, times 1.18. Okay, so year 3 amount. Does that make sense? Does her final expression correctly reflect the amount owed? Well, I'm going to test it out with my calculator. I'm typing in 450 times 1.18 raised to the 3rd power. And I got 739.36. Yeah, I believe they got it. The amount after 1 year was 450 times 1.18. The amount after 2 years was 450 times 1.18 times 1.18. The amount after 3 years was 450, 1.18, 1.18, okay, which is all the same. We get the same answer, right? So that means that the expression that we can use for this, my dog is snoring so loud, 1.18 raised to the x, where x is the number of years. Cool. All right. Let's move on. Oops. Okay, so let's compare some student loans. Suppose 3 people each have taken loans of $1,000, but they each pay different annual interest rates. For each loan, write an expression using only multiplication for the amount owed at the end of the year if no payments are made. Okay, I'm going to make this a little bit bigger. Cool. So if we're borrowing $1,000, we're going to write some expressions here. So loan A is 12%. So we're going to have $1,000 times 1.12 raised to the x. Okay, or $1,000 times 1.24 to the x, or $1,000 times 0.306 to the x. Okay, so that'd be our first year. Oh, that's our first year, so we actually don't need the x's. Okay, I'm instantly out of space, so I know you guys can do this on your own. So for year 2, I'm going to have 1,000 times 1.12, 1.12, right? That's for loan A. Loan B, 1,000 times 1.24, 1.24. Ooh, I just saw a mistake for loan C. Sorry about that. 1.306. So year 2 for loan C, 1.306, 1.306. Okay, way out of room. That'd be year 2. Year 3, I'd have 1.12 written 3 times. Okay, 1.24 written 3 times. 1.306 written 3 times. Okay, I certainly can't write this 10 times, so I'm using some shorthand now. Raised to the 10. 1.24 raised to the 10. Raised to the 10, which means for year X, I'm just going to replace that 10 with an X, and that'll give me any year, right? 1.306 to the X. And that's if no payments are made, okay? That means that the amount of money is just going to grow and grow and grow. Okay, number 2 says use graphing technology. Okay, give me a second and I will do that for you. So that question number 2 says use graphing technology to plot the graphs of the account balances. So we have loan A, B, and C. And we see that the loans with the higher interest rate are growing much faster. Okay, this would be the 30.6%. I think this was 24%. And then we have 12%. So grows much faster, right? Question 3 says, based on your graph, about how many years would it take for the original unpaid balance of each loan to double? So we want to know where it reaches 2,000. Sorry, oh, I can't, there we go. Let me get this stuff out of here and get a new highlighter. So 2,000, how long does it take? So for loan C, it looks like it takes 2.5 years. Okay, that's for loan C, 2.5 years. Let's write it up there. Loan B. Looks like loan B, it crosses the 2,000 mark. About 3 years. And loan A, 6 years. Yep, 6 years, 3 years, and 2.5 years. Okay. So loan C stinks. That's actually the end of lesson 15. So go ahead and work on your problem set. And remember, you can text me if you have any questions at all.